Hi, everybody. So this is Get the MVP. And I'm Aaron.
I'm Colin. Yeah, we forgot a Who Am I slide, so sorry.
We're both fourth years.
Yeah.
Cool. Yeah.
Okay.
Anyway, so what is Git? Git is the most popular version control system in the world. It is what people use around the globe to collaborate on projects, to keep their projects updated without compromising while keeping logs of what changes are made to their projects. This is an example of distributed version control system. It is also open source, which is cool. It was originally developed by Linus Torvalds in 2005. For those of you who don't know, what is version control? Version control systems are software tools that help teams manage changes to source code over time. As development environments have accelerated, version control systems help software teams work faster and smarter. It is basically just a way to track changes to code, and it allows developers to revert their changes, as we'll talk about later. But it means that every developer has a local copy of all their changes, and the server can manage those differences. Everyone on a team can pull the code, commit changes, branch, and merge all together without causing issues, and can do so asynchronously.
Yeah, so for the history of Git, initially development started in April 2005. Started because the source control management used for Linux kernel revoked their license, and Linus Torvalds got this. So could not find any free software capable of meeting what he wanted. So he decided, I'm going to make my own. And yeah, so his design criteria was super specific, and nothing really met it. And again, he's going to make his own. I already said that. Yeah, he turned over maintenance of Git to Junio Hamano in July 26th, 2005. And Git had its 1.0 release on December 21st, 2005. So in total, it was written in about something like 6 months, 7 months. So pretty quick development there. This is the initial commit for Git. Just thought it was kind of funny. There's an explanation onto why it's called Git. There's 4 actually. Just a random 3-letter combination of letters. Stupid, contemptible, and despicable. Simple, take your pick from the dictionary of slang. Global information tracker, if you're in a good mood. Or goddamn idiotic truckload of shit, if you're not. Yeah, so just thought it was kind of funny. Next, we're using Git. A lovely photo of our esteemed president here. Yeah.
Alrighty. So the first part of using Git is cloning. This is used to create your repository from your Git server onto your local machine. Typically done at the beginning of a project and is a one-time operation. In Git, there is no difference between the working copy generated by the clone command or the original from your Git repository. When it's run, a remote connection is created to the original to create that local and is able to make differentiation between the two easier. This is done over one of 3 protocols: SSH, HTTPS, or Git, which is using things like GitHub's the application that you can get on your computer. Like, you know what it's called? Yes, GitHub Desktop. Thank you. From there, you can make changes, and then the next thing you do when you want to update your repository, once you've made your changes on your local machine, is staging. This is done with the git add command, and this command can be used to specify what files you've made changes to and that you want to save those changes. This does not have to be every change you've made since the last time you've updated your repository. The goal of this command is to set the stage, so to say. It's so you can set up specific sets of changes as opposed to every change at once. This command does not actually make changes to your repository, but it is rather logged to be organized in a readable manner. From there, it's showtime, which is the next one. It's your commit. This command can be used to snapshot the staging area and the changes that have been added to it. These saved changes are then made and saved to your local repository, not the remote one. These commit records record the entire file, not just saying, oh, this line has changed, but rather, oh, there were changes made in this file, here's the whole file. Going back to, it's a snapshot of whatever changes specifically that you wanted to be stored in that commit. You can make these messages custom to say, oh, changes were made for this specific service, rather than just saying changes were made for A, B, C, and D in the whole repo.
Pushing and pulling. This is where changes are kind of sent over to the remote repository on Git. So these commands, they're used to check changes to the Git repository itself. So push is actually what's done after you commit a change. Push just sends that saved commit into the remote repository. And then from there, you can pull, which is just pulling changes from the remote repository into your local one, making sure you're up to date, or other stuff, depending on what you're working on and who you're working with. Especially important if there are multiple people and changes might happen after you go to bed or when you're not working on stuff. So it is very useful to always have the latest changes. Otherwise, you get stuff called merge conflictions, which aren't fun to deal with.
One of the other important commands is your revert. Now, revert is not undo. Revert is not turn back to a previous time during the project. Revert instead takes a look at the commit that you want to undo and creates an inversion of the commit, and then saves that as a new, more recent commit in your repository. So it's not, so when you go back over the logs, it's not, oh, there are now commits missing. There is a second commit that is undoing what you've done. And that way you can still see the change history.
Another esteemed photo from Drew Young here. Ways of using Git. So GitHub, I'm sure pretty much everybody here is familiar with it. If you're not, popular software has multiple features to Git, such as access control, feature requests, continuous integration, and wikis. It was bought by Microsoft a few years ago, and as of 2023, or June of 2023, is the world's largest source code repository. GitHub Copilot, I know that's been brought up here a couple times in the news section, is from them. GitHub Enterprise is a self-managed instance of GitHub for use by enterprises or companies and organizations. GitHub Pages is just static web hosting. And then Git Gists is just paste bin with version control. So pretty cool extra stuff. Another one, GitLab. This is another, it's very similar to GitHub, slightly different. It's open source, operates as a freemium model, and has roughly 30 million users compared to GitHub's 100 million. So RITSEC uses GitLab primarily for competitions. Red Team uses it. Cool stuff on there. But yeah, Git. You can just use regular Git, but you don't get access to all the cool stuff in GitHub or GitLab. And you're using a CLI. So this is what you look like because you're in there. How you should use Git. Another great photo of Shandy here. Secrets. It's very easy to commit secrets or other sensitive information in GitHub if you do not sanitize your commits or your code. Secrets can include accounts, passwords, keys, configuration data, etc. However, Git has a solution for this. It is the .gitignore file, which essentially designates files that should be ignored when you commit stuff. Code scanning is kind of a new thing. Relates to what we are as cybersecurity majors, in that it's a security tool to check code before it goes out publicly. Make sure there's no secrets on there, aka SSHPs, because those are bad. And if you look up on GitHub and search for SSHPs, you will find them. Don't do anything with them because that's bad. Just a disclaimer there. Branching. This is kind of another big one with Git. Very useful. And there's several different branching strategies, but there's three kind of main ones. Release branching, which is basically an entirely new release or version of the code, is entirely within a single branch. Feature branching, which is a new feature is getting added to the code, and that's entirely within one branch. Or task branching. Each task is entirely within the branch. Think tickets, something like Jira. Every Jira ticket would be a task, would be its own branch. This can get a bit tricky with merges. Keeping consistent strategy helps with that. Those nasty merge conflictions, as I mentioned earlier, this kind of comes into play here. And branches make collaboration between larger groups much easier. This is a screenshot from last night of Realm. It's a C2 being built by a couple of RIT alum and a couple of RIT students. But yeah, there's like 50 branches on this thing right now. All of these are for individual bugs that they found, different releases that they're working on, any new features, stuff like that. So this is good branching strategy here. Good job, Realm. There you go.
So to follow up, branching is what you do when you're done with a branch. Is merging. So merging is when you take a forked branch and integrate it into your single branch, into a single branch, which is generally main. If it's not main, why? This process takes your sequence of commits from both branches and creates a unified history of commits so it's possible to see the timeline changes overall in the code. This is also, as we've mentioned, where merge conflicts come into play. If you are trying to merge a branch with main, and there have been changes to the same files that you changed in your branch, you're going to run into some fun and annoying issues that come with trying to figure out where the changes are and how to merge the two files into a cohesive whole.
Yeah, I specifically requested this slide. That's me down there. You'll see why that's bad in a second. Protect main. So this is your main branch. This is where all your code is officially. This is the central branch. Testing within branches, separate branches, that's not main. Allows for mitigation of potential issues, such as broken code. And work should not be done in this branch, especially in larger groups of code bases, because it turns into 229 commits in branch. That's bad. Don't do that. This is like live, like now. So you can go look at this. But yeah. Or actually, I did one. Why should you use Git? Another great photo of our president here. Git makes life easier, simply put. If you're working in groups, it's an excellent tool in which to collaborate and get work done. If you're working solo, Git is an excellent tool in order to save your stuff and keep track of everything. If you don't like CLI tools, aka Git Bash, most IDEs and some text editors allow for direct integration with Git. That photo right there is what my VS Code looks like if I try and do stuff with Git. There's a nice little drop-down menu, and I can just select stuff, and it makes everything easy without having to type in stinky Git Bash commands, because GUI is better. And then yeah, so that's kind of it. Anybody got any questions? Yes, Chase. Merge conflictions, because they're awful. As for remediating it, it's talking with, so that was a larger project that I was working on while I was at John Deere. Just talking to the other person who made the commit and figuring out what they needed or if it was just old or what. Yeah, if you're doing it on your own, you shouldn't really run into merge conflictions because nobody else working on it but you. But if you are working on a larger project, that's kind of where this stuff happens. Kenny, I know you raised your hand. Do you have a question still? Okay. Yes. Offensively. Wow, that is a great question there, Kenny. So sometimes, code can be hijacked if somebody has access to an internal GitHub instance or GitLab instance, and other stuff can be added if it's not properly audited and secured. Sometimes, if you can gain access to GitHub or GitLab or whatever a company is using, you can get stuff on there, like secrets, before they've been sanitized for public release. Yeah, so there's a whole bunch of other stuff. Yeah, Kenny? I would also like to see the CI/CD pipeline. Ah, okay. GitHub runner. Yeah, okay. Automatic deployments, you're right. So I didn't really talk about that because this isn't really that hot. But CI/CD is thank you, Kenny. CI/CD is basically automatic testing and deployment. And offensively, if you are able to get in there and you can make your own deployments with it, and makes your life a little easier offensively, or if you can gain access to a organization's CI/CD pipeline, you can do some really funky stuff with their code and all their other stuff. So it's really bad if that's vulnerable. Don't make that vulnerable. But if you are a red teamer, it's really fun to have because it makes your life so much easier. Okay. Any other questions? So I'm gonna let Aaron take them first. No? Yes, Chase.
Yes, Chase. What is your question?
This question is for you specifically. Have you ever wished you could go back to the classic time, share your information on a certain small device?
A certain small device.
Yeah. So, do you know what that would be called?
What is that called, Chase? I'm not entirely sure.
It's a USB.
Yeah. There you go.